This lesson is on angle measures in polygons. And our targets today, first I can find the sum of the measures of a polygon's interior angles. And second, I can find a missing angle measurement in a polygon. There's a few vocab terms here, so we'll break down a couple of them. We've seen sum, the word sum before, as the total, if we add them up. We've seen angles, right? The measurement of the distance between two rays or two lines. And we'll look at a couple other of the terms here. So first of all, a polygon is an enclosed figure with straight sides. So in this example here, there's a pentagon, 5 sides, enclosed, and a hexagon, 6 sides, enclosed. And interior angles would be any of the angles inside the polygon formed by two adjacent sides. So a couple of the examples would be this angle here, but it could have been this one or this one. There's 5 interior angles here. And in the hexagon, there are 6 interior angles, and one of them is shown. Go ahead, pause the video, and this is something you should get into your notes. Let's begin by finding how many degrees in a triangle. This is the foundation for our work today, and it's something you've already learned. So the number of sides in a triangle, of course, is 3, and that produces one triangle, as shown here. And, of course, 180 degrees in every triangle is what we've learned. That's the triangle sum theorem. And so 180 degrees times one triangle is 180 degrees. Now, it's a little unnecessary to maybe show that right now. However, it will lay the foundation for this pattern that we're going to be looking at. How about how many degrees in a quadrilateral? Well, this time, we are going to choose any of the vertices, so A, B, C, or D, and we're going to connect from that vertex to each of the other vertices. So A to B, A to C, and A to D, right? You could have started from point B if you wanted to, and you would still end up with how many triangles? 2 triangles. So 4 sides results in 2 triangles. And if each triangle has 180 degrees, 180 degrees times 2 is 360 degrees. So remember this degree symbol, I didn't do that in the last example. 360 degrees in every quadrilateral. Let's take a look at how many degrees in a pentagon. Well, how many sides? 1, 2, 3, 4, 5. And I could start from any point. Maybe this time I'll start over here at point S and connect to each of the other vertices. There's 4 other vertices, but it's only going to create 3 triangles. So even whether you started at point T or U or Q or R, you would end up with 3 triangles. And see if you can beat me to it. 180 degrees times 3. $540 degrees. All right. Now, I want you to pause the video and try using the triangles to find out how many degrees would be in a hexagon. Go ahead and pause the video. So you could have started at any point, connect to all of the others, be careful that it is a triangle, a very skinny triangle. And we end up with 1, 2, 3, 4 triangles. So 6 sides results in 4 triangles. So again, we end up with 180 degrees times 4. And this time it's 720 degrees. Okay. What patterns do you see here? Pause the video and look for patterns. So obviously the number of sides is going up by 1 because that's how we're deciding what to do next is we're just adding another side. But the number of triangles is also going up by 1. And that's why we do that here. We are using the number of triangles. A more specific question would be, do you notice a relationship between number of sides compared to the number of triangles in each row? Take a look. So, do you see that the number of triangles is always 2 less than the number of sides that you had? So, if we were to continue or generalize this, actually, we're going to skip past heptagon for right now and look at n-gon. N-gon just means for any number of sides, where the n is the number of sides, the number of triangles would be what compared to n? 2 less than n. And so we could take 180 degrees, multiply by number of sides minus 2, and that'll equal the sum of the interior angles, the measurements, the total, okay? That will help you so that if you were given a 100-sided polygon, you wouldn't have to draw it all out and make all the triangles. You could use this formula or that pattern and say, oh, well, there's going to be 2 fewer triangles than there are sides, so that's 98 sides, 98 triangles, rather, times 180 degrees, and we end up with the total number of degrees. So that is shown here. Again, this would be a good place to pause and write down this statement and this formula. Go ahead and pause. One thing I want to mention is that when I set students loose to find the number of degrees on their own, a lot of times what I see is they'll meet in the middle and they'll start from every vertex and they'll say, well, a hexagon with 6 sides results in 6 triangles. Well, that's true, but we'd have to also realize that that's including all of these degrees in the middle, right? All of these angles in the middle are not part of the actual perimeter of this polygon. So they aren't part of the interior angles. So we'd have to subtract the total number of degrees in this full circle here, right? How many degrees are in a full circle? Do you know? 360 degrees. So with this strategy, you could do it like this. You could think about it like this. But in this case, you would say, all right, well, the number n times 180 would give you the total degrees of those 6 triangles, 6 times 180, but you'd have to subtract the 360. Okay? Well, actually, this formula here is the same as what we had over here, if we know how to use the distributive property. Do you know how to use the distributive property? 180 times n, that's where we get this part here. And 180 times 2 is 360. That's right here. And we're subtracting, so that's the subtraction here. So this would be another formula you could use if you think of it this way. If you like that way better, great. You can visualize it and think about it as that pattern. Okay, I want you to go ahead and with your own strategy, you could use the patterns, you could use the formula, but pause the video and fill in this row of about heptagons. So of course it would be 7 sides, which would result in 5 triangles. 7 minus 2 is 5. And 180 degrees times 5 would be 900 degrees. All right, so let's apply this and do one more problem where we can find the missing angle measurement in this quadrilateral. Well, we need to realize first that the formula would tell us, if we didn't have it already, there's 4 sides, so I'm going to put n equals 4. Then I'm going to subtract. I'm going to subtract 4 minus 2. That tells me there would be 2 triangles here. Okay, and 180 degrees times 2 triangles results in 360 degrees, right? So that's how many total degrees in this whole quadrilateral.
Can I?
Do you want to say hi to my students here?
Hi.
This is my daughter Elena. She's joining me for the rest of this video. So now that we know that there's 360 degrees, we can say, okay, 106 degrees here, plus 78 degrees, plus 90 degrees, right? This means a right angle, plus my missing value has to equal 360. Do you know what to do now? Add the sides, the angles that you know, 274 degrees, plus our missing angle is 360. How can I undo the adding these two things? Subtract. Subtract 274. If I show that,
Can I please cross the base on?
you would subtract 274. And what are we left with? X equals 86 degrees, if I did my math right. And I think that's what's under there. X equals 86 degrees. So in the end, hopefully with this video and with some more practice, you'll be able to say to these statements, yes, I can.